So this is a bit on conditional probability, which is starting on page 52 in the Walker book through to page 54. Sorry, it hasn't scanned very well, but we'll just work with it. Conditional probability, as we've talked about it, it's the probability of something happened given that a condition's already happened, for example. So yeah, we'll just talk through it anyway. So there's some ways, there's this way of showing this. This is the probability of event A happening given that event B has already happened. Sorry, you can sort of see that a little bit here. So for example, they've given here the event A is a student is in the arm wrestling team, and event B is a student in the bouldering team. Interesting. What's a bouldering team? So if we look at the first bit here, it says calculate the probability that a student is in the arm wrestling team given that the student is in the bouldering team. So we use this formula here. So we're looking at the probability that the student is in the arm wrestling team. So that's A, given that they're in the bouldering team. Okay, so the given bit is always that second bit there. Okay, so what we need to do is that we need to find the probability that they're in both. Okay, and divide it by the probability that they're in the bouldering team. So it's like saying you've reduced your sample size down a little bit. Remember when we did two-way tables, we looked at the whole, first of all, we looked at the whole table, and then we, given a particular condition, we just looked at that particular condition. And that's what that probability of B is sort of doing there. It is important that the probability of A given B is not the same as the probability of B given A. So we'll look at an example, for example. The probability of the student takes art is 0.15, and the probability of the student takes both art and design is 0.083. Calculate the probability that the student takes design given that he or she takes art. So we've got probability that they do take design. Oops, sorry, it's a bit. Given that they take art. So that's when you go, so on the bottom it's going to be the probability of A, and that's always the second term there. And then on the top is already written there is the probability that they take both. So that's where the 0.83 here comes from, is the probability that take both. And now because we're doing it just out of the students that take art, you have to divide it by the probability that they take art, and therefore we end up with that probability there. You can also do it by doing the table, which some people do. We know that the probability that they take art is 0.15. We know the probability that they do art and design is out that, and basically we're doing it like we did before with that probability. So we're just looking at the art column. So the probability that they do design and art is 0.083 divided by the total probability there, which is 0.15. Another way of doing it. Some people look at it by doing a probability tree. I don't know. I personally find that just using the formula is okay, or using that two-way table like it is there. And all I've done is the same thing. So the probability that they do art first is 0.15. The probability that they do art and design, so art and design, is 0.83. So the probability that they do design, given that they do art, is that number there divided by that number. And that's where the 0.5 comes from, of 0.5 recurring, sorry. Okay, if we just have a look at one more example. So the probability that the student doesn't take art is 0.85, and the probability that they take design, given that she doesn't take art, is 0.16. So we're actually given the conditional probability. So the probability that they do take design, given that they don't take art. So that's, remember that complement sign, that A dash sign. So we know that that is 0.16 recurring. Okay, sorry, that's a dot at the top. Okay, so that's where this bit here comes from. So we're asked to find the probability that they take design but not art. So that we're looking for actually the intersection of those two probabilities there. The probability that they take design and not art. So to rearrange that formula, they've just multiplied the probability of A dash over there, and that's where they get this formula there. And then just work that out as 0.012. And there's some alternate ways there that, you could see if they make sense as well. That's just using the table or probability tree as well. So hopefully that makes sense as well. Catch you later.